When it comes to plastic part design, it's not always just about the aesthetics. Take this plastic part we designed to cover the URB-E's battery case. This critical structural component not only needed to be injection molded ready, it also had to be durable enough to withstand any extreme operational use. In the next few minutes, I will show you how we took this part from prototype to final production by simulating both strength and injection molding analysis to guide our design process. For this design project, we went through 4 major revisions. The first revision was purely made for form and fitting. We needed an initial shape to fit the existing battery case, so we designed a basic model simply for 3D printing a prototype. We also needed to ergonomically place the USB ports for this battery case as a power source. We saw this as a huge benefit to the rider, as they would be able to use their phones for navigation and charge it at the same time. Our ultimate goal for this battery case was for easy removal and independently portable. Confident with this initial design, we were able to move on to the next design stage to consider the placement of internal components. For revision number 2, we started to think about function and purpose of this part. We needed to properly place the battery terminals and add wall supports. Additionally, this part also housed some very critical components such as the motor that controlled the torque of the URB-E and a few PCBs, so we added some additional supports to hold these components in place. Now that we have a functional design, we can start to validate this plastic part design both for manufacturing and operational use. Just like what Jordan did earlier with the fender design, I used Solidworks plastics to quickly check if this design will in fact fill during injection molding. Here we can see the part filling the mold without much issues. But before we give the OK for this part, here are a few things to consider. Number 1, this part has to have very tight tolerance to keep it flushed with the existing battery case. One thing we are aware of when it comes to injection molded parts is the possibility of warpage. Number 2, this part will endure external loads from the operational use, which we need to consider. To address number 1, which is the injection molding concern, we can use some of the more advanced tools available within Solidworks plastics. Running a warpage analysis, we can verify this part is currently warping up to 1.5 millimeters. This may seem like a small number, but remember, this part consists of very thin walls, meaning we are pushing the higher side of the fit tolerance. To address number 2, we can run a linear static analysis on this part to identify weak spots. Based on the placement of the battery cover, any impact on the front wheel would have a direct load on the battery cover. The result from the analysis shows a factor of safety of around 2.1. For this plastic part, I was hoping for a factor of safety of at least 3. A common method in plastic part design to increase stiffness and also decrease warp is to add some strengthening features like ribbed walls and gussets to areas that are most susceptible to high deformation. This brings us to revision number 3, adding strength to the part. As a first pass trial, we added a ribbed wall to the area with the highest stresses. Results-wise, a slight increase in the factor of safety to 2.4 from the previous 2.1, and decreasing the warp to 1.45 millimeters, which is exactly in line with our goals for this revision. Continuing down this path of ribbing to increase strength, we were able to identify areas with high stresses and deformation to add more ribbed features, which brought us to revision number 4, the final design that we released for production. Taking a quick look at the factor of safety results, we have an increase of factor of safety to 4.4, which was way above the minimum requirement of 3, And for warping, we brought it down to around 1.38 millimeters. Lastly, before wrapping up this final design, a quick check one last time to ensure it fills without any issues. To summarize this design process, we started with revision number 1 to create a basic part to 3D print a prototype to check for form, fitting, and ergonomic placement. Revision number 2 was to focus on function and purpose, where we started to add features for internal component placement. With the functional design in place, we ran preliminary analysis and results from Solidworks simulation and Solidworks plastics showed we needed a stronger part, which made way for the addition of ribs in revision number 3. Rerunning the same analysis showed promising results, which then brought us to our final design, increasing the factor of safety by more than 50% and decreasing the warp by almost 10%. Being able to run a structural analysis, injection molding analysis, and making geometrical changes through each iteration in parallel really helped in designing the best version of this part. With results like these, we were confident that not only this part can be injection molded, saving a significant time and cost, this part will be able to withstand any operational impact, keeping the internal components safe.